Hi, welcome back, and today we're going to be talking about antiderivatives. The antiderivative, I guess you could say, is essentially the opposite of the derivative. Now, that's not the reality of it, but that's how we can think about it. For example, a derivative graph would go position graph to velocity graph to acceleration graph. Sorry, the camera's cutting off a little bit. An antiderivative goes backwards almost. So you go from acceleration to velocity to position. So remember, the antiderivative is the symbol and means underneath the curve of the graph. So as we see in this graph, the antiderivative equals the area under the curve. So, taking the antiderivative example, the antiderivative of 3x cubed plus ax squared minus 2x plus 5. There should be a dx. I'm very sorry about that. But anyway, so first, it's 3x. We'll just do this first one first. So basically, the exponent, we'll go back a little bit more. Oh yeah, so the 3x, the exponent is added to 1, and then the whole coefficient is multiplied by the reciprocal of the exponent. So 3x to the fourth is multiplied by 1/4. So then we repeat this for the other terms, and we get 3. So we get 3/4 x fourth plus 8/3 x cubed minus x plus 5x. And then finally, you have to add c to the whole equation because there's a constant that we don't know about. So sorry, my marker's being a little difficult, so I'm going to switch to a Sharpie. Taking the antiderivative with a set interval now. So now we're moving away from not having anything that we know about and going more finding the antiderivative from 2 points on the graph, from 2 to 5. So basically, first we take the antiderivative again using the steps we know from before. So we get x cubed plus x squared minus x. So then we do f of 5 minus f of 2, which would be 5 cubed plus 5 squared minus 5 minus 2 cubed plus 2 squared minus 2. So we get 145 minus 10, which is 135. Antiderivatives can also be found using Riemann sums. Right Riemann sums, left Riemann sums, and trapezoidal Riemann sums. What this basically means, it's a manual way of finding the derivative by splitting up a graph into very small portions. So on a right Riemann sum, you draw rectangles, and each rectangle, the edge of the right side is what hits the graph's points. Now this is done again on the left Riemann sum, except it is the left side of the rectangle. That we are now touching the graph with. For the trapezoidal Riemann sums, we have points connected to make trapezoid shapes, and these are all estimates, and depending on the graph, you'll have overestimates, underestimates, or as close as you can. Trapezoidal Riemann sums are probably the closest you'll get. That's all for today. Thank you.